So I have shared my whiteboard. You would be able to see that in a few seconds. Are you able to see the whiteboard?
Yes, I can see it.
Okay. Now the next chapter is basically algebraic expressions and formula, in which we have different subtopics. So since we have quite a lot of subtopics, let's just start our discussion with the first subtopic. Okay, now we know how to solve an equation. For example, let's talk about solving a simple linear equation. Let's say the question is x plus 2 equals 4. If you have been asked to solve this equation, what do you do in solving? You need to find the value of x by making it the subject. So it would be x, 4 minus 2 equals 2. Okay, this is simple. Let's say that your question is given that t equals 4 under root h by 32, calculate the value of h when t is 12. Okay. Now, if they only had the question till here, we would not have been able to do it, because this question has two unknowns. One unknown is t and the other unknown is h. If we have to solve an equation with one variable, equation should be 1. And if we are interested in finding out the values of both these variables like t and h, we need to have two equations, just like we do in simultaneous equations. Do you know what simultaneous equations are?
Yes.
Okay. So this means that obviously they are interested in finding the value of h when t is 12. What we need to do is, first step is to use t equals 12 in, let's say, 1 in I, and it would be 12 equals 4 under the root h by 32. And now since we have to find the value of h, so I will make it the subject. So I'll take 4 to the other side. That would be 12 divided by 4 equals under root h by 32. And this is 1 time, this is 3 time. And now I have under root on this side. In order to make h the subject, I need to get rid of the under root. So I will square both sides. This will cancel the under root. I have 9 into 32 equals h, right? So this is how basically we solve such equations. So finally the answer would be 9 into 32. That is, h would be 288, right? Now this was a very easy example, but the only thing which you need to understand is it could be that you have two unknowns in the equation. You have to find one unknown and you would be given the second unknown. You just have to plug in the value of second unknown, which basically would be known, like they would tell you it is t equals 12 or whatever the value is, and you would be able to find the answer easily, right? So did you understand this question?
Yes.
Okay. Now this was a very simple subtopic. That is fine. Okay, this was the first thing. Okay, this is something which we have been doing already, so I don't want to, spend a lot of time on this. Let's talk about the next thing. Now here we have translate each of the following expressions into an algebraic expression. Okay. Now, this is extremely important because this is the base of problem solving. Let's say that first question is you have been told in English that you need to divide 8x by 24y. So how do we solve such questions? What would be an equivalent algebraic expression? Any idea? It is divide 8x by 24 by y, so it would be 8x divided by 24y, right? So it is 1 times 8 and it is 3 times, so it would be 1 by 3 x by y, and finally I can write it as x by 3y, right? Did you understand this?
Yes.
Okay. Right, this was an easy example. Let's talk about another one. This is extremely important because this is the basics of problem solving in mathematics. Okay, let's say the statement is add 2x to twice 3y. Okay, now you need to add 2x to twice 3y, and it would become 2x plus 2 into 3, that is 6y, right? Is this correct?
Yes.
Okay, let's talk about some more examples. Okay, let's say this time the question is subtract 5x from the half of y. Now, what would be the algebraic expression equivalent to this statement? Any idea?
5x minus 1 by 2y.
Okay, so you are saying it would be 5x minus 1 by 2y. But what is the statement? The statement is
1 by 2y minus 5x.
very well done, excellent. Okay, because it is subtract 5x from the half of y. So this basically is 1 by 2y. And since you need to subtract 5x from this, so the thing coming after from will be written first. Then we have minus 5x. Okay. So this is what we will get. Okay. All right. So let's talk about some more because this is very, very important. Okay. Two less than the product of 3 and x. So yes, Turhan, what do you think about this part? What would be an equivalent algebraic expression? Any idea? Okay. So it is 2 less than the product of 3 and x. Okay. So if we break this question, it basically has the product of 3 and x, that would be 3x, and 2 less than the product of 3 and x. So it would simply be 3x minus 2, right? Did you understand this, both of you?
Yes.
Okay. All right. Let's talk about some more. Now we have, it's the part 3 times the difference of x and 2 Think about this. Meanwhile, I'll write the next one. Okay. So what about the first one? Any idea?
3 bracket x minus 2, which will give us 3x minus 6.
Okay. Okay. Wait. You are saying 3 bracket x minus 2, that will give you 3x minus
6.
6. Okay. So it basically was 3 times the difference of x and 2, right? So the difference of x and 2 is x minus 2, and 3 times that will give you 3x minus 6. Okay, very well done. Excellent. Now we have twice the number x less 3. Any idea?
I don't understand the question.
Exactly, because it is written this way. Okay? It is twice the number x. It would be 2x less 3. Like this number is basically twice the number x less 3, right? This would be the answer. This would be the algebraic expression for this one. Did you understand
Okay.
it now? Okay. And the last part is 2 more than 3 times the number x. 2 more than 3 times the number x. Since there are no commas, it totally depends on the reading style, but you need to be careful with it. Okay, so basically 2 more than 3 times the number x. So 3 times the number x would be 3x, and 2 more than would be this, right?
Yes.
Okay, perfect. Acha. So this is how we convert some translations into algebraic expressions, and we can also do it for equations, but we will do that once we enter the problem solving domain. Okay, this is done. Let's talk about simple factorization. Factorization. Okay, how do we factorize? Let's say that we have different expressions. Let's talk about the first one. So let's say if we have x to the power 4 plus 5x square plus x cube y, we need to factorize. When we say factorize, you should think about something of this type, that you need to take out the common number, the common variable, right? So all these expressions have x. So what should I factorize? What should I take common?
X square.
X square. Very well done. And I will be left with x square plus 5 plus xy, right?
Plus
Okay.
x square y.
Y x square y.
Okay.
Yeah, okay. Very good.
I got it.
Okay. Acha, now let's say if we have 12 x square y to the power 8 z to the power 6 minus 18 x y z to the power 4. Now we can take so many things common. We can take a common number up. Let's talk about the number. What is the biggest number which I can take common? I can take 2 common, I can take 3 common, but what is the biggest number? 2 or 3?
3.
6. Okay, I was just tricking you. It would be 6 because 6 into 2 is 12 and 6 into 3 is 18, right? So we have to take 6 common. Okay, and x. Again, what is the biggest x factor? What is the biggest x term which I can take common? Since it is x to the 1 here, so I can only take x common now, right? I cannot take x square common because I don't have x square here. Uske baad I can take y common because I have y to the 1. And then I can take z to the what's common?
4.
Very well done. So this would be 2x y to the power 7 z to the power 2 minus 3 and what? That's it? Yes, Sunny?
Yes,
That's it,
because
okay?
the
Yes, because we have written everything already here. So when we multiply that, we will get this directly. Okay. Let's do some more questions of this type. Let's say we have 15 a to the power 4 b square minus 10 a to the power 4b plus 5 a to the power 5 b cube. Okay. Now you need to take out the common things. What do we have? We have numbers. Yes, we can take a number out. The biggest number is 5 because 15 is a multiple of 5, 10 is a multiple of 5, and 5 is also the multiple of 5. Okay. What else can I take common? We have
a power
a in every term, yes, and the lowest power of a is a to the 4, and then we can take b
b.
common. So simple b. Very well done. We will be left with 3b minus 2 plus a and b square, right? Is this correct?
Yes, it's correct.
Okay. Let's talk about another question then. Let's say this time we have 6 x cube y to the power 5 plus 4 x4 y cube minus 24 xy. Okay. Now what can I take common? What is the biggest number?
2.
2. Very good. Okay. Okay. And what about the x term? Simple x and
Yes.
then simple y.
Y.
Very good. That would be 3x square y to the power 4 plus 2x cube y square minus 12, and that is it. Okay. All right. So this is how we factorize such expressions. We need to continue this discussion. For that, let's talk about some quadratic identities. Okay. Let's say that you have been asked to factorize x square plus 2xy plus y square. How are you going to factorize this? Do you see anything common? Yes, you have x in both these terms. Yes, you have y in both these terms, but there's nothing which is common in every term, right? So for such expressions, we have some quadratic identities. The first one is a plus b square is basically equivalent to a square plus 2ab plus b square. The second one is a minus b square. It is a square minus 2ab plus b square. And the third one is a square minus b, sorry, it should be written over here. Okay. It is a square minus b square, and it is basically equal to a plus b and a minus b. So, Neem, are you familiar with these?
Yes.
Okay. Now we know that whenever we have such expressions and we have been asked to factorize them, we can directly use these values, right? We can directly use these expressions. For example, if this was the question, this is x squared, this is y squared, this is 2xy, so this would be x plus y whole square, right? So this would be the factorization of the above expression, right? Did you understand this?
Yes, you did the first identity on this?
Yes, yes. Okay. So let's talk about some more factorization stuff. Let me just clean the screen and now we can talk about some examples. Okay. Let's say we have now it's different factorization questions. Let's say you have 2x minus 3 minus y x minus 3. Okay. And let's say the second one is AB minus A minus B plus 1. Okay. Now, Saneem, you cannot factorize these things directly. Do you know how to solve quadratic equations?
Uh, in the first one, first we have to multiply them.
Okay. Okay. If we multiply them, it would be 2x minus x minus xy plus 3y. Okay. And then, do you see anything common?
No.
No, right? So for such expressions, we need to do things differently. Okay, that's fine. Okay, let's say if you have a question of this
Would it
type.
be x minus 3, 2 minus y?
Yes, very well done. Excellent. Because this is the common factor, x minus 3, and then it would be 2 minus y. Very well done. Excellent. Okay. And what about this one? Now, first you will take things common out in both these. Okay, this would be A. This would be b minus 1. Now you can take minus 1 common and you will have b minus 1. And now what would be the factors? Again the same thing. B minus 1 into
A
A
minus 1.
minus 1, right? Okay,
Yes.
very well done. Excellent. Okay, let's do some more questions. Let's say you have y 3 minus z plus x z minus 3. Let's say you have 1 plus a into x minus y minus 1 minus a, and the last one is x square minus z square minus z square minus x square. Okay, let's try factorizing this one. Now this bracket and this bracket, they are not same. Okay, there's a difference of minus sign. What we can do is we can just write down y. I can take minus common, right? So I can write it as minus 1 into z minus 3 plus z minus 3. Now, do you see z minus 3 in both the terms?
Yes.
So you can write it as z minus 3 minus y plus 1. And you can rewrite it just so it looks much better as 1 minus y. Right? Did you understand this?
Yes, I did.
Okay, let's talk about this one. Again, we have something of similar type, but it's not exactly same. So I can rewrite it as 1 plus a into x minus y. And now I can take minus 1 out just so I have 1 plus a, just so these two factors are same. Now I can take 1 plus a common and I have x minus into minus would become plus y. Okay. And what would be the factorization of the last one? So again, initially they are not same. I will write it as x square minus z square minus z. I'll take -1 out just so I can rewrite it this way. And now these two terms are same. So this would be x square minus z square into x minus into minus plus z. Did you understand it this way?
Yes, I understood.
Okay. All right. Okay. So let's talk about some more factorizations. Let's say this time the question is x square plus 9x plus 20. Okay, so do you have any idea how to factorize such expressions?
Middle term breaking.
Very well done. Excellent, excellent. Okay, so you need to think of two numbers such that when you multiply them, you get 20x square, and when you add them, you get 9x. So those two numbers could be the factors of 20, maybe 4 into 5, maybe 2 into 10, right? But we know that 2 plus 10 or 2 minus 10 is not 9. But this looks like it would be helpful. So we can do it this way: x square plus 4x plus 5x plus 20. I'll take x common. This would be x plus 4. 5 common. This would be x plus 4. And finally, we have x plus 5 into x plus 4, and these would be the factors, right?
Yes, ma'am.
Okay, let's talk about some more examples I'll give you, and you can just do them. Let's say we have x square plus 6x plus 5, and the second one is x square minus 8x plus, sorry, okay, you have 3 minutes just to find the factors and tell me. Okay, I'll ask you after 3 minutes. Both of you, Turhan and Salim. Yes. Any idea?
Just 1 minute.
Oh, sure, sure.
For the first one, I got x plus 1 and x plus 5.
X plus 1 and x plus 5. Okay. And what about the second one?
X minus 1, x minus 7.
Okay. And what about you, Turhan? Are you getting the same factors? Yes. Okay. Let's do it together. Okay. Yes. Let's see if your answer is correct or not. So basically, two numbers such that when you multiply them, we get 5. 1 into 5 is 5. And when we add them, we get 6x. So x square plus two numbers look like 5 and 1, x plus 5x plus 5. I can take x common. I will have x plus 1, and then I can take 5 common. I will have x plus 1, and this would be x plus 1 and x plus 5. Very good. Okay, now again we have an algebraic expression. We need to factorize it. It's a quadratic expression. We do it by middle term breaking. So this is the constant number, that is 7. We need two numbers such that when we multiply them, we get 7x square, and when we add them, we get minus 8x. So it would be x square and 7. And here, what would be the numbers? Minus x and minus 7x. Because when I will multiply minus x with minus 7x, I will get 7x square. When I will add them, I will get minus 8x. This would be x minus 1. Minus 7 can be taken common, and I will have again minus 1. This would be x minus 7 and x minus 1. Turhan, did you understand this?
Yes.
Okay. All right. So let's talk about the last one. Let's say we have x square plus 13x plus 40. Okay. And you have been asked to solve this equation. How do we solve this equation? Again, things are same. You have to solve this equation. In order to solve this equation, first you have to factorize it. Once you have your factors, then we know how to go about this. Okay, so what would be the factors? You need to think of two numbers such that when you multiply them, you get 40x square, and when you add them, you get 13x. So you will start thinking about the factors of 40. It could be 2 into 20. No, it cannot be, because that will not give you 13. Okay, it can be 8 into 5. Can that give you 13? Yes, it can give
Yes.
you 13. Okay, very good. So it would be x square plus 8x plus 5x plus 40 equals 0. We need to take common from these two numbers, from these two expressions. This would be x, and then we have x plus 8 plus 5, and then we have x plus 8, and this would be x plus 5 into x plus 8 equals 0. Now we have two expressions or two factors that are being multiplied, and they are equal to 0. How do we go about this? We can say x plus 5 equals 0 and x plus 8 equals 0, and this will give me x equals minus 5 and x equals minus 8. Did you understand this?
Yes, ma'am.
All of you?
Yes, miss.
Okay. Acha. Now in this case, we were able to make the factors easily, and we were able to do it this way. What if there's a question in which you are not able to make the factors, but you have to solve it? How do we go? How do we solve such questions? Let's say, for example, if the question was x square plus 13x minus 41 equals 0. How do we solve such questions? If you are not able to make the factors, would we write down no solution? No. We have a formula to solve quadratic equations, that is x equals minus b plus minus under root b square minus 4ac divided by 2a. And what are a, b, c? It is basically, for equations of this type, ax square plus bx plus c equals 0. Now, using this formula, you can solve any quadratic equation, right? Even if you are able to make the factors, you can solve those with this formula as well. For example, if we talk about our example, we have x square plus 13x minus 41 equals 0. What is my A? My A is 1, B is 13, and C is minus 41. So if I will use the formula, what would I get? X equals minus B minus 13 plus minus under root 13 square minus 4 AC over 2A, right? Is this correct? Yes, guys, is this correct?
Yes.
Okay. So I will
Yes.
have x equals minus 13 plus minus under root 13 square is 169 minus 4 into 41 will give me 164 divided by 2, and 169 plus 164 would be 333. So I can just rub it and write it here directly. I don't have space. Okay. And now we just need to find the values, right? So I can do it here. One answer of x would be minus 13 plus under root 333 divided by 2. And the other one would be x equals minus 13 minus under root 333 divided by 2, right? So even if you are able to make the factors, even then you can use this formula. But obviously using this formula is very difficult than, just applying the, using the factorization method, right? But in questions where you are not able to factorize, you can always just use this formula and find the values of x, right? So did you understand this?
If it was x square minus 13x minus 41, then we would have written only 13 plus minus.
Minus 13, if it was minus 13.
Yes, in the question.
Yes, 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 exactly. Minus 13 hoga. Since we have minus p, it would be minus into, it would be minus into b, right? So minus into b is plus 13. That in that case, this would have been the case. So it would have been plus 13 and plus 13, right? Okay, let's talk about another quick example. Let's say that the question is x square minus 12x minus 80 equals 0. Now it could be that you end up getting some factors, but it is not necessarily true, right? So you need to think about it using the formula. It is x equals minus b plus minus under root b square minus 4ac divided by 2. Are you studying this formula for the first time, Sunny? Or you have seen this in
I've
school
seen.
before? Okay, all right. So minus into b is minus 12 plus minus under root 12 square minus 4. A is 1, c is minus 80. Because this one is my A, this 12 is this minus 12 is my B, and this minus 80 is my C, divided by 2 into 1, right? And I just need to
How did you write minus over here? Under root के नीचे minus 12 square नहीं होगा?
because I know that minus 12 square would basically be 12 square, no? Whenever I have square on negative number, it basically is 1, right? It basically becomes positive, silly. But yes, you are right. Let's write it this way. Okay. So it would be minus into minus plus 12 plus minus under root 144. 4 into 8 is 32. So this would be minus into minus plus 4 into 80, 320 divided by 2. And again, you just have to simplify it. One value of x would be 12 plus under root 464 divided by 2. And the other x would be 12 minus under root 464 divided by 2. Right? These would be the two values of x. Did you understand this, everyone?
Yes.
Naira and Turhan, did you understand this?
Yes, miss.
Okay. So that is it for today. We will do some more questions tomorrow.